Good morning, everybody. Today we are doing the next section of topic 5, which is 5-2 exponential function and day 1. And we're going to talk about some brand new graphs that it's not linear. In other words, not a straight line, but a curved line, okay? So before that, we are going to do some reviews on how to simplify exponential expressions. So, going from positive exponents to zero exponents and negative exponents. And later on, we'll be using these numbers and exponents and as well as the answers to generate a graph on the xy plane. So let's take a look at the first example. Well, 3 squared, back in previous math classes that you had, it means 3 times 3, which is just same as 9. So I want to clarify that 3 squared is not 6, but it's 9, so that's easy. Well, 3 to the first power is just 1/3 of the 3 by itself, so that's just same as 3. Well, and remember from previous lessons, a number that raised to 0 power, it's going to be 1. So 3 to 0 power is 1. And then if it's a negative exponent, you're going to make it a fraction, put a 1 over. So 1 over 3 to the first, which is just same as 1/3, and I have to write that correctly. And then finally, 3 to the negative second power is just same as 1 over 3 squared, and then which is the same as 1 over 3 times 3. And we know that 3 squared is 9, so the answer is 1 over 9. So that is the review for the first half of the set of problems. Well, the second set of problems is very similar, but then you have a coefficient in the front. So we're going to use order of operations. So between multiplications and exponents, we're going to simplify the exponents first. So 1/2 squared, that's just same as 4 times 1 squared over 2 squared. Now you have to be careful. 1 squared is just 1. And then 2 squared is 4. And then 1/4 of 4, right? So that's just same as 4 over 1 times 1 over 4. If you put that in your calculator, that's just same as 1, right? So 4 times 1/2 squared, the answer is 1. Well, moving on to the next problem. So 4 times 1/2 to the first power. So anything to the first power, it's itself. So that means just 4 times 1/2. So half of 4 is going to get you 2. So your final answer is 2. Then the next problem, 4 times 1/2 to 0 power. So a number to 0 power is always 1. So 4 times 1, which is just 4. Then when you have a negative exponent, right, negative first power, you first have to flip the fraction. So that just means 4 times 2 over 1 to the positive first power. So once you flip the fraction, your negative exponents becomes positive exponents. Then from there, anything raised to the first power is the same thing. So 4 times 2 over 1, which is just same as 8 over 1. And that's just also same as 8, okay? Then finally, when you get to the negative second power, same thing, you're going to flip the fraction. So 2 over 1 and change the negative exponents to positive exponents. Then after that, you distribute. So make sure that, well, if I were to show work more, make sure that every single base has its own exponents, and then you distribute like this. So that means you have 4 times 2 squared over 1 squared. Now, of course, you could also show work here where, you have to make sure that from the first problem, make sure that everything has its own exponents before you distribute a square to get to this answer right here. So back to the last problem. So 2 squared is 4, 1 squared is 1. So 4 times 4 is just 16. Now notice that there's a pattern for these set of problems. If you look at set problem number 1, you notice that, from one answer to the next answer, it's divided by 3. Right? And of course, from bottom to top is multiplied by 3. Well, likewise, for the next set of problems, you notice that from one answer to another, from top to bottom, it's multiplied by 2. And then if you would go from bottom to top, it's divided by 2. So there seems to be a pattern with involving division or multiplication, depending which direction you wish to go, top to bottom or bottom to top. So there seems to be a pattern. Well, we're going to use that pattern today, as well as these answers, to look at exponential functions. In 5-2 exponential functions, we're going to take a look at one type of nonlinear functions. Nonlinear means not a straight line, because in the past we have been learning how do you graph a straight line, and then this will be one of the graphs that is not a straight line, another type of graph. So exponential function is always in the form y equals a times b to the x power, where a and b are numbers. X is the input, or the independent variable, and then y is the output, which is the dependent variable. And in this exponential function, your value of b It's always positive. It's never negative. And the number A could be any sign. It could be positive, negative, fractions, things like that. And of course, B could be fraction as well. So, but this has to be positive. The B has to be positive. So let's take a look at example 1. Example 1, if I were to ask you to graph y is equal to 3 to the x power, you notice that the x is on the exponents. And to graph that, we're going to use the very, very primitive method, right? The most elementary method where we're going to create a XY table, and then we're going to plug in 5 inputs, which is usually 2, 1, 0, -1, and -2. So we're going to copy 3 to the x power into all of these. So 3 to the box. Instead of putting an x, we're going to put 3 to the box, right? And then in each one of the boxes, you're going to replace the box with the corresponding x value. So, for the first row, it's going to be 3 square. The second row is 3 to the first, 3 to the 0, 3 to the negative first, 3 to the negative square. Now remember, we have simplified these problems already from the review. So 3 squared is 9, 3 to the first is 3, 3 to the 0 is 1, 3 to the negative first is 1 over 3 to the first, which is 1/3. And then 3 to the negative second is 1 over 3 squared, which is 1 over 9. Okay? So let's box these answers first. These are the y values with the given 5 x values. Then from there, all you have to do is graph these 5 order pairs. So let's first graph 2, 9. Where is 2, 9? Which is right here on the xy plane. So this is checked. 1, 3. So 1, 3 is right here. So this is checked. The next one is 0, 1, which is right here. So this is checked. The next one is -1, 1/3. So -1, 1/3. Now 1/3 is a little bit less than half. So just kind of approximate yourself. Probably right here. Okay. And then -2, 1/9. Now 1/9 is even a smaller fraction, which is very, very close to 0, but not right on the x-axis. So which is right here. Now be careful when you connect these dots, right? We're not going to have any corners or any sharp edges. We're going to try our best and connect it very smoothly. So you notice that this is very, very vertical. And then gradually it will get flatter and flatter, but do not touch the x-axis. Do not touch the x-axis. Kind of just get close to it, but do not touch it. And you should have 2 arrows on both ends of the graph, okay? So this is the graph of an exponential function. It's first look flat, and then it starts getting, steeper and steeper slope over time. Kind of like a roller coaster going up from left to right, if you will, okay? Well, if you notice, if I were to continue the x's, let's say x is -3, -4, you notice that this fraction is going to get smaller and smaller and smaller, but it will never get to 0. So there is an invisible line that we have to draw, which is a dotted line right at the number that the graph gets close to but do not touch. And we call this the horizontal asymptote. Well, it's horizontal because it's, flat, it's going left and right. An asymptote, asymptote, is a line that the graph gets very close to, an imaginary line, a dotted line that the graph gets close to, but do not touch it. It will never touch this. It will get very, very close to it to a point that you think they would touch, but they don't actually. So this is the horizontal asymptote, and this is also part of the graph. You have to graph that on your homework as well. Well, let's talk about some key feature of this function, of this graph. Let's find out x-intercept. Well, let's take a look at this graph. X-intercept means, is this graph ever going to touch the x-axis? In this case, it doesn't. So it's going to be none. There's no x-intercept. What about y-intercept? Does it crosses the y-axis on the number? Yes, it crosses right here at the value 1. So we're going to say 0, 1. Okay. Now the equation of a horizontal asymptote, remember, back in, I think, topic 3 or topic 2, right, the equation of a horizontal line is always y equals to a number. So since this is on like a ground level, not above and not below, you're going to say y equals 0, like this, okay? And remember domain and range. Domain is how left and right the graph extends. Well, if you continue this graph, it's going to go to the right forever. If you continue to this part of the graph, it's going to go to the left forever. So your domain is all real numbers. So we're going to say all real numbers on Pearson, okay? Now, of course, remember for interval notations, you're going to write -infinity to infinity, right, with parentheses on both ends, okay? And then for the range, I noticed that if I were to, look at this graph, right? As it's continuing more towards the left, it's getting close to 0, the ground level 0, but it doesn't touch it. But if it goes more to the right, it's going to go up forever. So you're going to say the range is going to be y. It's going to be always greater than 0. This is the answer you're going to put for your Pearson's answer because they only ask you to put it in an inequality notation. But in the future, if your teachers want you to put in an interval notation, remember, the lowest number is 0, not including 0, so we put parentheses, and then comma all the way up infinitely, so it's, infinity like this. But again, for your Pearson's answer, you just need to put the box ones, okay? Because they don't require you to write it in an interval notation. Well, let's take a look at another example. So this equation, exponential function is y is equal to 4 times 1/2 to the x power. Well, let's do the same thing. So first of all, we should have an xy table, and we're going to copy the equation 5 times like this, and we're going to put a box, okay? And then same thing that in each box, you're going to fill in the corresponding x value, okay? So that would so inside the box, you're going to replace them with 2, 1, 0, -1, and -2. Now remember, from the review sections, we learned how to simplify this already, but let's actually show it one more time. Because you're going to do this on your own as well when we're doing Pearson's homework and maybe sometimes Flipgrid as well. So you're going to have 4 times, and then 1/2 square just means 1 square over 2 square, which is same as 4 times 1 over 4, which is just same as 1. Okay, then when x is 1, it's going to be 4 times 1/2, which is just same as half of 4, which is 2. And then when x is 0, well, any number raised to 0 power is 1, so 4 times 1, which is 4. Then when x is -1, so you first flip the fractions, so 4 times 2 over 1 to the first power, which is same as 4 times 2, and you get 8. Okay, and then on the last row, when x is -2, again, you flip the fraction. So 4 times 2 over 1 square, which is the same as 4 times 2 square over 1 square. Now, 2 square over 1 square is 4 over 1, right? So 4 times 4 is 16. So that's why we get these 5 answers in the first place from the review. Well, let's plot them. So first, we plot 2, 1. Let's find what's 2, 1. 2, 1. Now this is 2 right here, so half of 2 is 1. So 2, 1 is right here. Then 1, 2. So 1, 2 is right here. 0, 4. 0, 4 is right here. -1, 8. So -1, 8 is right here. And then -2, 16. So -2, 16, which is right here. You notice that this time it's not a roller coaster going up from left to right, but it's roller coasters going down from left to right. So we're going to graph it the same way. First, you should have a very steep slope in a curved manner, and then it gets closer and closer to the x-axis, but do not touch it. And you should have arrows on both ends. I am checking that on your homework. Then again, since it gets very close to the x-axis, but not touching it, you should draw an horizontal asymptote. So that way you kind of remind yourself, hey, I'm not supposed to cross this line, okay? So let's find the key features again. So for the x-intercept, I'm going to have, let's find out, well, is this graph, I'm touching the x-axis. And the answer is no, it gets closer to it, but it does not touch the x-axis. So we're going to say this is none. What about the y-intercept? Does it crosses the y-axis? Yes, it crosses at 4. So we're going to say 0, 4 like this. Now, of course, there's another way for you to find out the y-intercept. Well, y-intercept occurs, remember, when at x equals 0. So even though, let's say if I were to use a calculus, use something to cover up the graph, well, if I were to ask you to find the y-intercept just from the table, all you have to do is look at the y value when x is 0, which is right here. When x is 0, the y value is your y-intercept. So that's how you get 0, 4 without looking at the graph, okay? Well, the horizontal asymptote, again, is on the x-axis, so it's going to be y equals 0. That's the equation of the horizontal asymptote. The domain, well, how left and right this graph goes, well, it goes left infinitely, and it goes right infinitely. So again, it's going to be all real numbers for your Pearson's versions. But for interval notation, it's going to be -infinity to infinity with parentheses on both ends. And then for range, again, looks like the lowest point of this graph is on the ground level, which is 0. And then the highest is all the way up to infinity. So we're going to say, well, the y value must be greater than 0 for your Pearson's answer, or for interval notation, it's going to be starting at 0 all the way to infinity with parentheses on both ends. But I'm just going to box the Pearson's version of answers, right? So these are your two final answers for domain and range. Well, let's take a look at one more. Since we're doing two examples, might as well go over this one. Now, this one is not on the review, but you're doing the same way. So when you have an equation y is equal to negative 3 times 2 to the x, first, you're going to copy the equation into 5 times into the xy chart. And then later on, we're going to replace the box with the x values, the corresponding x values. So now we're going to replace the box with 2, 1, 0, negative 1, negative 2. So let's do that. Let's start with the easier exponent. So negative 3 times 2 squared, we're going to follow the order of operations. Well, 2 squared is 4, so that just same as negative 3 times 4, which is negative 12. When x is 1, then you have negative 3 times 2 to the first power. Now, 2 to the first power is just 2, so negative 3 times 2 is negative 6. Okay, when x is 0, 2 to the 0 power is 1, so that's the same as negative 3 times 1, which is negative 3. Have you noticed the pattern? From negative 12 to negative 6, I cut it in half. Then negative 6 to negative 3, I cut it in half. So guess what we're going to do? We're going to cut it in half as well. So you kind of see a pattern, or you should see a pattern in the xy table. Then from there, you start working with negative exponents. So negative 3 times 2 to the negative first is you put as a fraction 1 over 2 to the first. So which is the same as negative 3 halves, okay? And then when x is negative 2, again, you make it a fraction. So negative 3 times 1 over 2 squared, which is negative 3 times 1 over 4, which is negative 3/4, right? And then these are your 5 y values. Let's plot them. So the first order pair is 2 comma negative 12. So find 2 comma negative 12, which is right here. When the order pair is 1 comma negative 6, 1 comma negative 6 is right here. 0 comma negative 3, which is right here. And remember, when x is 0, this is your y-intercept. Can we just answer that right now? So 0 comma negative 3 is your y-intercept, okay? Then when x is negative 1 comma negative 3 halves. Now this is between negative 2 and negative 1. So it should be negative 1, and then it's like right here. And finally, when the order pair is negative 2, comma negative 0.75, which is kind of close to negative 1, my order pair is like right here, right? Kind of getting close to the x-axis, but not quite. Then guess what? This one is actually kind of like the exponential function, but kind of reflected along the x-axis. Remember, when you have a negative coefficient in the front of a parent function, the graph just reflected along the x-axis. So it's like a water reflection. It just flips upside down. So you get close to the x-axis and then get steeper and steeper as if you are falling down like this, right? So it's going to keep falling and falling like that, okay? So that's your exponential graph for this equation. Well, let's fill in these blanks. So for the x-intercept, I want to see, well, is this graph touching the x-axis? Well, generally never. Actually, it's never. So it's actually none here. We already answered the y-intercept, so let's skip that. For the horizontal asymptote, well, again, it gets very close to the x-axis, but never touches the x-axis. So we're going to say y equals 0. With your domain, same thing. You're going to notice that this graph going left and right forever. So it's going to be all real numbers. And in interval notation, it's going to be negative infinity to infinity. And then for range, now this time it's different now. The highest point, it almost gets to 0. But the lowest point, it's going dropping all the way to infinity. So your range is going to be y is less than 0 this time. So any negative values is y is less than 0. And in this case, your interval notation is negative infinity, comma 0 with parentheses on both ends. But again, on Pearson's homework, you just have to know the inequality notation, not the interval notation, unless you get to higher level math classes. Well, finally, we're going to sum up everything. So far we generate 3 graphs. And if you noticed, there are certain behaviors when you see certain characteristics in the equations. Like, for example, if for the a, right, we always call the first number in the equation a. And then for the number that has an exponent, we always call that a b. Okay, so remember, the exponential equation is always y equals a times b to the x. So a is your first number, which is all these 2 and negative 2's, and b is the number with the exponent, which is the 3 and the 1/3. So for the first case, if your A is positive and then your B is 3, which is greater than 1, then your graph would look like this. Without graphing it, the shape of the graph, it's like a roller coaster going up. Then right here, if your A is positive, but then your B is less than 1, right? Because this is like a factor, right? Every time X increases, the Y decreases by 1/3. So it's getting smaller and smaller. It's like a roller coaster going down. Then next, if your A is negative, but then your B is greater than 1, well, it's just like a reflection. Come look at these two graphs. Well, this is positive 2, is above the x-axis. This is negative 2, is below the x-axis. It's like a water reflection. Likewise, on the last example, look at these two. Well, when the A is positive, it's, above the ground level, and it's like a roller coaster going down. But then when A is negative, it's a reflection. It's kind of a reflect over the x-axis, water reflection. So this is kind of like something going up, but it get a plateau. It's like almost getting to the top of the hill. So that's how you could tell, just without graphing, the shape of the graph when you notice some characteristics for the number A, whether it's positive or negative, and the B, whether it's greater than 1 or less than 1. Okay, and that will help you for your Pearson's homework. So thank you very much. The next couple minutes will be the instructions for you to remind yourself how do you get to your Pearson's homework. Thank you.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page. And you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. You click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks, so if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the third time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step, step by step, step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So well, to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that it's not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it, and then boom, only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.